Pasha, hello. Kyiv is calling.
Yes, hello. Can you guys hear me okay?
Yeah, everything is fine. How are you doing?
I'm good, awesome. How are you?
I'm also good. I know that it is pretty early for you.
Well, it is 5:20 to be exact, but that's okay.
Okay, all right. Hope
Excuse me.
you are feeling good and you are prepared well. And I want just to give this online stage to you, and it's time for you to shine. Have a great talk.
All right, thanks. Thanks a lot. I have to apologize. My voice is a little cracking. I'm still recovering from whatever, and it's been 2 weeks, but you guys are way far out there, so don't worry about it. My name is Pavel Veller, like I was introduced. I am originally from Minsk myself, but for the last 13 years, I've lived in the US. And I'm broadcasting to you from Atlanta, Georgia. I don't know if you guys watching US elections, but Georgia is currently a big deal. And the thing with the 5:20 a.m., I wanted to find a spot where it's rather quiet and I don't have interference from the outside. But then I did the wrong math with the time zones. I forgot the time zone change and got myself into a 5 a.m. slot. So here I am. EPAM probably needs no introduction to this audience, but I'll tell you briefly that we are a large software services company. We operate in 31 countries. I forgot how many cities we have. And typically when I present at conferences, I animate myself on stage. This setting is very different, not something I do regularly. So instead I animated my slides. I tried. So I guess if nothing else, I hope you guys are going to get a good show. And the good thing for you, unlike in the traditional setting, if you had enough of me, you can just stop watching. And I'm not going to notice. But please sit back, relax, and enjoy. I came to talk about Anywhere. If you go to anywhere.io that we announced in the title, what you'll see will look to you probably like just another freelance marketplace, like the likes of TopTal. But look deeper. We're trying to build a place for people to work, learn, grow, and be part of a vibrant community. It does start with work, obviously, because, well, we are a software services company. That's what we do. We believe that we're pretty good at it. We've been growing for the last 25 years. And of course, we need more engineers. We started exploring the workforce without borders for a couple of years already. But the 2020 and COVID specifically just accelerated everything. Now, if you are not sure if things can be done remote in our industry, now everybody knows that they absolutely can. But instead of telling you about Anywhere from where I am, let me give you a perspective from how you can look at what Anywhere is. And I need to give you some context before we dive into technology and the architecture. So bear with me for a little bit. When you think about where can you as a software person of different disciplines work, you largely can distill that to three different choices. You can work at a product company, and that can be, small startup or big B2B product. It can be an enterprise building systems for themselves. But at the end of the day, you have some distinct characteristics of working at a product company or in a product setting. You can be free, that's why free and freelance, and just consult with different companies and do different things sort of on your own schedule and as you please and from where you please. Or you can work at an outsourcing company, which I prefer to call services because that's what we do, but basically work for different clients and do different things at different times. These three options are not really distinctly different. They're of course overlapping, but they have their own distinct characteristics. What we're trying to do with Anywhere is have all of that in one place where you don't have to necessarily make the choice and where you can have all the pieces of those three different work environments in one place that also brings along a large community and different opportunities to learn and to grow. Now, you don't have to trust me on that. You can always try for yourself, but that's what we're trying to do. Now, what I came to talk here about is not necessarily what Anywhere is, because that would not be interesting for 30 or 40 minutes. I wanted to tell you how we're building it and what kind of product is it and what architecture challenges we faced and how we solved them. This talk in the architecture track, so do expect diagrams, many animated diagrams about what we're building. And what I'd like to do, I'd like to first give you a quick snapshot of where we started. That'll set context. Everything happens sort of for a reason and has its own roots, and I need to tell you what ours were. I'll walk you through how, as we quickly grew, we arrived at the architecture that certainly, like, seemingly stopped working for us. And I'll explain why and what was not good about it. I want to walk you through how we transformed that architecture step by step, why we're doing it, what were the targets, what tools and techniques we have used, and how, without necessarily noticing, though Fasama was apparent in the beginning, we changed the perspective. We changed how we think about what we're building. And that's what I really would like to share with you, because all of you are building systems, right? We're building products, applications, services, APIs, front ends, experiences, you name it. And I hope that some of the lessons that we've learned through Building Anywhere will be beneficial to the large audience at Devoxx. So we'll start with me telling you what we started with Anywhere about a year ago, or give or take. Let's see. We made a mistake from day one. We did not start fresh. We built, a couple of years ago, we built a system. If you think of an enterprise doing certain things internally and doing it as an enterprise open source. Now, add a layer of crowdsourcing within the same enterprise on top. So you get this crowdsourcing for enterprise open source concept. Basically a platform where people can list work that needs to get done. People can come in and volunteer to do the work. So basically contribute, those the name. And that system, it's nice. It's been working for us, and it's been built by those contributors, which over time, not necessarily contributes to it being nicely and cleanly architected. But it's a decent system. So we had it for a couple of years. We cloned it and we built the system that we named very succinctly EPAM Plus, which was the same idea of crowdsourced enterprise open source, now with the marketplace concept on top. And that's where we were when we decided that we needed to build what became Anywhere. And we had this brilliant idea that, look, EPAM Plus looks exactly, in quotes, right, like what Anywhere wants to become over time. Just Anywhere wants to be that in public, and EPAM Plus is that, but in private. So why don't we take that and build Anywhere on top? Now, we didn't really think that over time of building Anywhere, our perceptions of what Anywhere needs to be will shift. And what we thought we really needed, we not going to need really anymore. Plus, we were really on the crunch timeline, so we needed to go fast and release the first version fast. So we cloned that clone of a clone. And that's how Anywhere sort of came to be. Now, as we now know, we didn't need all of that. We're not going to use all of that. We're actually going to completely decommission that baggage that we're carrying over. And we will indeed start fresh, or really start that part fresh. And if I were to do it again, I would certainly, spend 2 more weeks and start fresh. We didn't. First mistake. So we're carrying all of this over with us into, let's call it day one. Now, technologically, because I'm going to need to talk about what it is internally, Anywhere is nothing, was, at least at the time, nothing special. There was a big React app, used to be delivered with a thin layer of Apache. It could have been Nginx. And then underneath, there's a lot of Java APIs, or at the time, we called it Java backend. And I'll get to that transition from the backend to APIs over time of this presentation. So watch for that. But this is our APIs, delivered in the Spring Boot Java app, powered by Postgres, one of my favorite databases. I like all of them, but I have a special place in my heart for Postgres. So we're using Postgres. I need to add a little more color to it so that you guys get a feel of what kind of application is that. And I'm going to start by telling you that we were, and some of it's still true, and you'll see, running it in containers, which was a good thing. Everything is automated. Like we have a decent CI, we have a decent CD pipelines. We automate through GitLab Actions. And again, I've used many different ones over time. I've seen teams use different ones over time. I came to like the modern GitHub Actions. We're using GitLab Actions very similarly. So that's what we're using. We also, I got to mention, using Content Stack. Modern cloud, SaaS, subscription-based, API first and API only CMS. If you haven't heard of Content Stack, you likely have heard of Contentful. They're not the same, but they're in the same category. And if you have a mental model for Contentful and for what it is, Content Stack will likely fit right into that model. So we're using Content Stack. And because our original React app was client-side render, interactions with the CMS as far as the front-end experience goes are pretty straightforward. We're just pulling content at rendering time in the browser. So that's a little context. Let me give you more. In reality, our Spring Boot app is actually larger because of all that baggage we carry over from the day 0 into day 1. And I need to tell you about some other neighboring applications that we're integrating with. And to do that, I need to bring a user into the picture. And one of my favorite colors is orange in general, but today, as you'll see, it's indeed orange. So user will be orange in my diagram. Now, what we have in addition, of course, we have identity access management. You need to sign in, authenticate, have a profile, all the good stuff. That's a traditional auth, nothing special. And there's a little role that the backend plays with code, token exchange, and token validations. And then I'll name 3 systems. There's more, but I'll name 3. Again, just so that you understand that we're not in isolation. And I'll briefly tell you what they are. So unified profile. I wish we could just, take your personal data and store it and use it, but we can't just do that. Working in different geographies, we have to be compliant with government privacy regulations, like think GDPR, whatever Russia laws are around privacy. And to be compliant with that and not have to reinvent it every time you work with PII, we have a service within our ecosystem that basically does all of that. So we outsource it to the service, but we need to integrate. Interview portal, as name suggests, handles everything interview. Scheduling, feedback collection, test administering, and some other things. And the staffing desk is our sort of backbone of our operations, right? Projects, people, planning, forecasts, talent acquisition workflows, many different things. All of this is homegrown and custom built, decent systems, and we need to integrate with them. So we do real-time synchronous API to API integrations. We do asynchronous when we store events into our own database, and then we have jobs processing them and doing the right things later over time. And you probably expect this. Everybody these days in anything more complex than Hello World application runs Kafka. So do we. Not we within this project. We as an enterprise, we have a Firehose data hub, and many systems just send events, consume events, read out of it, put something to it, and we do the same. Now that didn't really affect our architecture in any way, but just so that you also understand why we had to bring that baggage along. Many of these integrations came pre-built into that contribute an EPAM plus cake. And that was one of the appealing attributes why we decided to just go with it, because we had all of this. We had the foundations for all of them. We could have rebuilt them, but we took them along with us. All right, so this is how we launched. I'm guessing February, so right before COVID. Well, COVID was already happening. We just didn't yet know, not where we were. And from here, very quickly, we arrived at the architecture that stopped working for us. And I need to walk you through and explain how that happened. So what happened first thing after we launched? Now we're live, right? Systems live. Interest is growing to it. Not really like large growing, but we have a lot of ideas. We have a decent roadmap. So we start growing. And the growing part first started with new applications, new experiences. We're smart enough not to package them up into the same app. So we built two new apps. I wouldn't call them micro front ends. I know the term is sort of out there. It's just more front ends. Let's not call them micro. They're not necessarily small. They're not designed to be like, little pieces. They're just designed to be individually deployed and individually worked on. And in a way, for me at least, this whole concept of micro front ends, microservices really helps you gain team independence and do different things at different times, at different speeds. Not necessarily makes like your architecture in any way better. It definitely makes it more complex, for one thing. I like it. It helps us be faster in different places, and that's why we did this. Now, these applications, one of them is for business landing that work into the Anywhere ecosystem. One is for the automation of the onboarding process, the paperwork, and all the other things that typically require people interventions. Now they don't. And these applications need their own services, which we also started packaging and deploying separately. I, again, wouldn't call them microservices just because they're not necessarily small enough or, intended to, or carry along with them all of the complexities of modern complex microservice architectures. But I know that the team who is working on them, they call them microservices, and that's fine. I mean, for me, they're just services, or rather APIs, but we'll get there later. Now, some of these new front ends also opted to do Next and server-side and some pre-rendered, so which is better for our SEO. I like that better too, and team likes it better too. So we also have some containers rendering our experiences now. And this is the time when this guy comes in. Now, I wish I could see you and ask for a round of hands of who knows this guy. I would expect that the Java audience at Devoxx, at least some of you guys know this individual. His name is Jay Hipster. I gotta tell you, I'm not necessarily a big fan. I hope I'm not offending anybody. It's a decent open source project. It definitely gets you started quickly when you need to build services, microservices architectures, puts you on the right path as far as thinking, and gives you lots of tools. Some of them probably you don't need, and getting tools into your architecture that you don't need, but you think you might need later. It's sort of not exactly Yagni, right? It doesn't, in our case, that sort of hurted us a little bit. But the team started following the JHipster prescriptions, templates, or patterns. And we ended up having a gateway, which is one of the JHipster pattern, which we needed, of course. We needed to route through the services. And we also ended up with the service registry, for which the team picked HashiCorp console. Now, not only, in EPAM do we sort of build applications and build systems, build APIs, and build experiences, we also happen to have our own blue cloud. You can read about it if you're interested at cloudepam.com. And before you start laughing, I'll give you 2 reasons why a company might want to have their own, not just virtualization, but their own cloud. Well, their own virtualization, it's where you start, but then you want to operate it like, modern way. So you'll end up having a sort of a cloud that you can automate. And 2 reasons are cost and compliance. And 10 years ago, when AWS was actively starting and sort of gaining market share, not everybody was convinced that it's going to be the future. And then second is, it wasn't really as cheap as it is now. All is comparative, but it wasn't. And we do have compliance problems. So we certainly need to have our own runtimes and our own compute infrastructures, and that's what we have. So this used to run in OpenShift, in our own cloud, okay? And to complete the picture, in our OpenShift environment, there's also HA proxy that handles all the routing and basically is this big load balancer up front. And I want to show you two planes in this architecture that I'll be thinking through and talking about as we transform this, what you're looking at. First plane is the front door, is the HTTPS plane. That's where all requests comes in. Everything comes in through there. That's where routing begins, right? Is this the static asset? Is this my server-side rendered page? Is this my API call? Like, what is it? It starts happening there. And you'll see how we certainly didn't have enough capabilities in just basic balancing and basic routing. And the second plane is the API plane, is when you're actually calling your API. What can you do through that plane? How much routing happens there? What else you need to do? Do you need to do any payload transformations? Do you need to do versioning, rate limiting, like whatever the case might be? That'll happen in the API plane. And in our case, in this architecture, that API plane is that gateway from the JHipster pattern library. Okay, now, and this is the architecture that stopped working for us. And I'm going to walk you through things that we didn't like about it. They're not screaming that something is not right. None of it was wrong. It's a decent architecture, I'll tell you that. It was, and yet it didn't work for us. Excuse me. Our platform wasn't a monolith anymore. It wasn't the very beginning. It wasn't. But it felt very monolithic. Our approach to releases and to deployment was rather monolithic. Somehow it felt heavy and not transparent. And some of it might have to do with where it's been running, like that whole OpenShift, our own environment. Some of it might have been related to how it's been architected and written. JHipster brought some of abstractions we certainly didn't need that were in a way of thinking what happens in the architecture. Second is subtle, but as you'll see the progression where we went, you'll understand why I'm talking about this. When you run in a compute cloud, all you have is compute. And everything you need to do other than compute, you have to run and operate yourself, or you have to build it. And doing either takes time and effort and slow you down. So we didn't have much of managed services other than compute, and didn't like that. Now, with API Gateway being written sort of by us and being just another service, we can do anything we want on it, but we need to build it again, right? Now, we're using Zool. We weren't building the gateway itself. So the machinery is the Netflix open source, but it still didn't feel like we were thinking about this as APIs. We're thinking about this as just a backend that exposes endpoints, like controllers or whatever they are, REST endpoints. And overall, the team wasn't moving fast enough. Now, I'll tell you, don't confuse velocity with speed. We had velocity. Velocity wasn't a problem. We didn't have speed as observed or appreciated by, let's call them stakeholders. So it wasn't moving fast enough or nearly as fast as we knew we could go, but for some reason we couldn't. And all of that while we're experiencing rapid growth. So COVID is in full swing, interest is like through the roof, and we need to move faster. Now, this is not the first, likely not the second time that I'm working with a team that, sort of has this, what sounds like, you hope it's simple, you hope there's an easy answer, but really feel like a systemic problem. It can be quality, can be speed, can be a combination, and usually you need to look at 3 different angles and look at them at the same time. And I'll spell them out for you. So it's team, product, and technology. And team, I mean individuals. Do you have too many? Do you have too few? Do you have the right ones? Expertise, skills, commitment. Now, and then how does the team operate? The forming, norming, storming, norming, performing. What stage are you at? If you're not at the performing stage, what stage are you? And how do you get to the next one? And what is missing? And why can't you get through that sort of threshold? and also all the engineering and development processes that goes into producing your work product. That's all team. Of course, important, because if it's not working to the level of your liking or expectations, you can't produce. Product is everything that you're building, your roadmaps, your features, your strategy, tactical thinking, strategical thinking. If that's not, again, in order, if it's hectic, your technical decisions are hectic. Nobody wants big design up front, but if you not organized on how you think about your product, it'll be very hard to build something that's sustainable and over time stays at the right level of quality and the right level of expectations. And third, of course, is technology itself. What do you do? How do you apply this? What do you run? What do you use? How do you use it? How do you cook it, basically? Now, I'm not going to talk about first and second today during the presentation. I'm happy to answer your questions when you join the Q&A room. You can bring them along. I'll talk about team and product and what we've done in those two areas. But today, for you, I want to talk you through and walk you through technology change that we did, because that's really a technology software conference. So let me walk you through what we've done with the technology transformation part. First thing we did was very subtle, but was very important to us. I call it infrastructure shift. We changed colors. We changed colors from blue to orange. It was very uneventful. Well, I'll tell you, my DevOps team had to work quite hard because they needed to rewrite all the pipelines, all the automation, infrastructure as code, all of that had to now do not the OpenShift wrangling, but the EKS wrangling. But other than that, it's all the same. If you look back to the blue picture, and then you look back to, again, to the orange picture, it's really not much different. Yes, there's no HA proxy. There's a different balancer because that's what AWS does. But everything else, because it's all in containers, was just moved in to a new infrastructure. So our planes, remember, they didn't change. So nothing yet happened to capabilities of our architecture. We just moved it somewhere else. And it was important, and you'll see why and what it did to us. But as a first step, we did this. We didn't even move production, I'll be honest. We moved all the lower environments, all the feature branches, all the bug fixes, all the release environments. Everything moved into AWS. The team switched all the processes, QA to AWS, and we kept running the same containers in our original OpenShift environment. While this was happening, we wanted to do something else. Now we're in AWS. And next thing we wanted to do, actually an opportunity came up to us by itself, which we didn't necessarily expect, but we have these partners that we're working with that we want to publish our vacancies on, and they'd like to have them as well. So we need an ability to push them into those partners. Remember Content Stack that I told you about? Content Stack not only is used as a web content management, not only does it power the experience that you're looking at, the web content, we also use it for vacancy postings. I mean, why build an administrative interface if you can use something that just works and you don't have to operate, test, fix, or anything? So we didn't. We just appropriated Content Stack for using with the vacancy posting. Works, by the way, nicely. We used to pump vacancies from our internal system into Content Stack and then publish them for our experiences. And now we're likely going to reverse the process. The team that works with vacancy postings likes dealing with decent modern content management system. We built lots of automation around it. It has APIs, management API, delivery API. So when they need to do batch updates, script something, get some reports about what's there, it's very easy for us to write. And we do that all the time for them. So to satisfy these partners, we had to build a new service, a new API, I should say, that will pull vacancies from Content Stack and push them up to our partners. And we tried something new. Instead of just following the path that we were on, with the JHipster and the microservices that it now governs, we built this as a Lambda. And as a Lambda, we built it not in Java, we built it not in Node.js. And that was subtle, that was on the side, but it started what I would call, and especially for today, it started the Orange Revolution in our architecture. So that to the side for a little bit, because this was a side, sort of small side project. We needed to do an infrastructure upgrade. And I'll tell you what I really wanted to do first. And I wanted to do it a long time ago when we launched in February. You see that Apache right there? I mean, Apache has no business serving static websites in AWS. And we took it out. We deployed all the static assets, all the client-side rendered React app that are built at build time into S3, put it up through CloudFront, and now our HTTPS plane is a whole lot different. CloudFront is a CDN. I'll tell you, Lighthouse score jumped up 10 percentage point on that change alone because of HTTP2, I think. I didn't dwell on their algorithms, but we did nothing other than repackaged how we deploy, switched the DNS, and then boom, Lighthouse score is up 10%. So like that a lot. And I'll show you some of the CloudFront a little later, so you'll see. And also, of course, we have the API gateway because that Lambda at the bottom with the orange box in it needed API gateway to be proxied to it from those partners, because it's not a push API. They really pull from us. So we give them an API and they call it periodically, which meant that our API plane got actually more complicated because we have our original API plane sitting in containers, a little too low in the architecture, to be honest. And we have the gateway, the as a service gateway in AWS. So we needed to do something about this. So what we needed to do, we needed to clean it up, which meant take out the gateway and likely JHipster along with it, which we're almost done with, and take out the registry, because in Kubernetes, we don't need that. We can route within the services perfectly fine with just what Kubernetes can do for us. So we took both of them out, and the architecture streamlined. It started looking more like what I would expect it to look. Excuse me. Now, our API path can go like this, right, and go into containers, or it can go like this and go into Lambdas. But it's the API gateway that does that routing, and I'll show you. And when it comes to rendering the server-side Next.js, it really bypasses API gateway because there's no need to send HTML through the gateway. And I want to show you this. Look at this picture. I want to get out of here for just 1 second, and I want to show you how it looks, just to land this idea of how we do routing and how things work visually. So what you're looking at is CloudFront. You see all the different environments that we have. Like I mentioned that we deploy, I mentioned the features, the bug fixes, all of them are here. But I want to open just one. They likely all the same, unless in one feature we're testing a new infrastructure piece, then that environment is going to be different. But otherwise, they're all the same. So we have a number of origins. I'll try to do it larger for you. So we have the API gateway, the load balancer, and the S3 buckets for all the static stuff. We have a bunch of behaviors that I'm not going to walk you through specifically. What you need to see is this. This is the API plane that goes into the API gateway right there. And all of this are the, right there. That all are server-side rendered requests for different apps that run on Next. And if you go and look one layer down, if I go and look into the gateway, you'll see the APIs. You'll see the same. You'll see lots of APIs because we have lots of environments that run on Amazon. They all, again, will look the same unless you're testing new APIs. Bunch of routes declared on the gateway. Not all of them are spelled out. The big chunk of our APIs live in Kubernetes, in Node.js, not Node.js, in Java, in Kubernetes. So we have this proxy plus path, like catch all everything that's not this. This one is only authenticated APIs, those that require users to be logged in. So they governed with the authorizer. And if you look at integrations, you'll see that many of these APIs go to the NLB, so they go to Kubernetes. And some, and so far it's more and more, go to Lambdas right there. So that's what I showed you on this diagram. At least I wanted to just show you how it looks. It's exactly what I showed you here. Very transparent, very easy to understand, quite powerful because we have capabilities of routing in different places. So we finally cleaned up and arrived at a state where our HTTPS, the front door plane, is like we want it to be. It's CDN. We can cache things left and right, and we do. We run Lambdas for things like specific error handling that we need to do differently for URL rewrites or redirects. And if you wonder about the cost, I got to go back for a second. I need to show you this, guys. And you'll do your own calculations, but when you see this, right? I mean, I'd like to have a problem where I have so many visitors to my website that running Lambda at edge becomes too expensive. That's a good problem to have, isn't it? We don't have that yet. We wish, but we don't have that yet. So that's not a problem. So we have a powerful, I'm going to go back there. We have a powerful HTTPS plane. We have a decent API plane. Now we're using, those of you who are familiar with AWS, you can tell, we're using HTTP APIs, the newer, lightweight API gateway feature. If we ever need to use REST, we can. I mean, REST can do payload transformations. They can do a lot more on the gateway. HTTP is catching up, but we can. It's all there. And it's clean. Each one of them does their job well, and we don't have those black boxes. And without necessarily noticing, we have arrived at the stage of change of perspective. And I'll explain that as well. So take a look. The same architecture that you just looked at, but something about it is different. We're no longer running or operating or writing or developing things that we can use out of the box with just simple configuration. By this time, the orange revolution that I talked about wasn't sort of a full swing. Like embraced AWS, and we can't have enough of it. We started building more Lambdas, which was obvious because it's easier to experiment. We redid authentication as the first step. That was done when we were retiring the gateway, because now security and your login is handled through Lambda. It's the same auth, the same redirects and stuff. And now the token validations, like I showed you, happens on the gateway. By the way, it comes out of the box, JWT authorizer. We don't even run it. I'm sure AWS runs Lambdas for us, but we don't have them. We just configure the authorizer with what we want it to check. It'll do the signature validations. It'll read the keys from our access management system. Like all of that, it just happens auto-magically, which I like. We built search. We built file upload. We built the feed API that I mentioned. We'll do more of these. And we started using managed services. The search on anywhere.io is powered by Elastic. And it's the AWS managed Elastic. And the whole concept with, setting up the Elastic, feeding documents into it, building webhooks from the CMS to keep it up to date, Lambda in front of it to provide the search API for the web, probably took us 2 days. Now, it took us another 2 weeks to get it sort of solid and launch, but it was fast. We're one step away from using Dynamo for some of the new services that we're going to build. And like I said, on our scale right now, it's a decent scale, but it's going to take us a long while before Dynamo is going to get more expensive than RDS. Dynamo used to be more expensive when it launched. Dynamo used to be that you need to provision capacity, write and read. You still can, but you don't have to. You can be completely on demand. And that's how I would start until you know that your volumes require you to, go back to provisioned capacities, to reserved instances, and all the good stuff. So our architecture organized. I wish I could say it organized itself. No, we organized it. We spent time and effort organizing it while running on it. So the thing was, with the step-by-step transition, we never stopped building features either. So the system wasn't going through this and nothing else was happening. Because we didn't disrupt the majority of what we were doing with our APIs in containers, we could do everything else in parallel and in a way transparently too, many of those developments. And what we'll do now, we'll likely use more of managed services, SQS, SES. There's more in the pipeline for things we need to start building, that we're not going to run our own queues, not going to run our own email or anything. We're just going to use services that are there. And when I think about this architecture, what I see a block of APIs running in Kubernetes, and I do think about them as APIs now. I can go to my API gateway, I see my individual endpoints, I see where they're going, but I also know that I can take them out if I want to redo some of them or do something different. I see my API sort of plane very cleanly, and some of the APIs are in Kubernetes, in Java, some are in Lambdas, in JavaScript, or rather TypeScript, but I didn't date JavaScript. And we have a bunch of managed services we're going to use more of. And this architecture I like a lot more. It has a lot of breathing room. And it can grow, it can double, it can triple, and likely stay the same and remain as clean as it is, which I can't tell about and couldn't tell about the architecture that we had. And we're slowly arriving at what have we learned going through this transformation. And that's what I want to talk about now. Because I think some of this, if you take it out, if nothing else, take this slide, the next one, not this one, not the next one. Take it with you from this talk. What we've learned, and what I recommend that you do, is start fresh. The fact that we didn't is haunting us till this day. So we started in February, and now is what, November? So that's what, 9 months? And we only enjoyed having what we had for about 2 weeks, maybe 4. And then it was a problem, and a baggage, and legacy, and a dark corner that nobody wants to go look at. And we're still cleaning it up. We're not done yet. So if I could, I would definitely delay whatever needed to be delayed for 2 weeks in February and not do what we had done. So that's first lesson. So if you can, sometimes it's warranted not to, but oftentimes it's better and easier to start fresh. Second is whatever you do, enable speed. And that's a loaded term. But our main problem was not moving fast enough, right? And it had different reasons why we were not moving fast enough. But we didn't focus necessarily on let's fix problem X or problem Z, or I don't like OpenShift, I like Kubernetes better. No, it wasn't like, well, I mean, EKS. It wasn't that. It was just not moving fast enough. And looking at why and solving different problems. Remember the team, product, technology dimensions? So enabling speed was important. And a lot of it is in technology too, and in processes around technology. So that was important. Now, I talked about this in the beginning. I'll talk about this again. I'm an engineer. I love building stuff. I mean, I do. But I also like not building what I can just use. If it's solid, if it's available, if it's managed for me, and if the price is right. And many of the things in AWS and others, and I like others too, Azure and GCP, are priced very favorable these days. Your problem needs to be like, you have to be in a very sort of, it's a good problem when what you need to do, you can't run at the affordable, for the enterprise, of course, cost in AWS. Now, thinking in APIs is the next thing that we've learned. Changes how you think about what it is that you are operating and building. When you have a backend, then you think about the application or that deployment unit with all these intricacies internally. If you think about the APIs and focus on your APIs, and I'm sure these days everybody's building stateless and everything is sort of independent. But it allows you to, when you can see the APIs, like in our architecture today, I can open the API gateway, I see the plane, I can declare them all up, I can look at my swaggers, and I can decide which one I want to look at, maybe change something, maybe rebuild, maybe take it out. Thinking in APIs versus applications, even though seems to be semantic, it changes how you operate and how you build them. And finally, continuing on that note, rarely do you build like applications. Like it's oftentimes you're building an ecosystem, or you're building a part of an ecosystem. Remember the first slide, all these integrated apps? They're not over the fence consumers or producers. We need to be friends with them. We need to be good to them. Our APIs and their APIs need to talk to one another. It's an ecosystem, and it's built by, it's governed by different rules. It's built on different principles. We are getting closer. We're trying to live on the same principles. But thinking about your applications as an ecosystem, that needs to breathe and sleep and all that, that's helps you do the right choices with technology as well. So these 5 things is what I want to leave you guys with. And with that, I'll leave you sometimes for coffee or breaks. Thank you. That was it. I think I'm going to go and join the Q&A now, unless I need to do something else.
Hello, Pasha.
But I'm happy to
again.
see you in the Q&A. Yes. Hello.
Thank you for a great talk. We were impressed. And I have a question for you. So you named a lot of challenges that you got on this project, but what you are the most excited about at this project? What do you like the most?
Right now, I absolutely am convinced that we can take anything that we want to do with our roadmap, and we have a huge roadmap. We're going to build what we call EPAM Club. We're going to expose a lot of our learning ecosystem, like I promised in the beginning, through the Anywhere, which we have a lot of those apps. And I know that we are currently on a decent foundation to do all of the above and more. We first, not surprisingly, started with shrinking the team. And we're now ready to actually grow it again, because the architecture and the ecosystem that we're building supports it. We can easily onboard more teams and challenge them with building new experiences. And that's what excites me. So we can now move at double, triple the speed by simply growing the team and challenging them with doing more stuff. So that's what I like. And I also like what we're building. So Anywhere ecosystem and what we want it to become is extremely exciting. Some of my team members are Anywhere citizens, I guess I should say, like citizens of the world, the no borders workforce, and it works extremely well. And I enjoy it thoroughly.
Fantastic. Thank you very much for your answer. And one more question from my side. So you got a great expertise by transforming other big companies, enterprise companies. But what expertise you brought to the Anywhere project from your previous experience?
Well, I wouldn't say that I transformed enterprises.
Okay. How will you call it?
Let's be honest. Yeah, well, I build software systems. I can build them, I can cure them, I can retire them, and then through that work, we of course help companies do what they need to do, and we can transform how they operate. But it takes many people. It takes teams to do these things. I can't do it alone anyway. So what I know that I'm bringing, in this case to Anywhere, that I joined, relatively recently, even though I've been in and out, I think it's just the energy and the thinking. I've been doing services for like a little over 20 years. I've seen different things. I've learned different things. I know what works. I know what doesn't. I also have patience. A lot of times you just have to wait. Well, you have to do things, you have to change them, but they're not happening overnight. So patience, energy, and experience, the three things.